already signed on to Google Classroom. I thought that was awesome.
I was going to subscribe to your YouTube channel last night, but I couldn't find it.
It's Mr. Taft Math, all one word. And Mr. is spelled out M-I-S-T-E-R.
I just said MR.
Yeah, no, it's M-I-S-T-E-R. All right, so here we go. So what we're going to do is we're going to talk about the different types of numbers that exist, which might sound a little boring, but I think it's kind of cool, and exactly where the numbers fit in, I think it's kind of interesting too. So this whole page, this giant box that fits everything, is what is called the real numbers. Which sounds like a weird thing to call a system of numbers, like real, but there is such a thing as an imaginary number, and we might get to that a little later in the year, but that might need to be a mystery for Algebra 2, so we'll see. So everything that's on this page is a real number, and we're going to kind of talk about these, like the way that you learned them, and also the way that they were discovered by people. So when you first learned to count, does anybody, like, if you remember, in like way back, it was forever ago, I know, but when you first learned to count, what was the first like set of numbers you learned to count by?
1 through 10.
2, 3, 4. Right, 1 through 10, and you thought you were so awesome. Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you were like, this is great. So those are kind of sort of what the natural numbers are. Except the natural numbers don't end at 10. The natural numbers go 1, 2, 3, 4, and then they go on up forever. So they go up as high as a number can possibly go. No fractions, no decimals. And these are the first numbers that human beings discovered in general too. As far as we can tell, these are about 20,000 years old. It's kind of interesting talking about like the history of numbers, because the first evidence that we have, that historians have of anybody counting, is this thing called the Ashango bone, which is where people would count like their sheep on it. They'd make marks. I have this many sheep, and then they'd count the marks and count the sheep. There are some cultures in the world that actually don't count numbers at all, believe it or not. There are some cultures that just have 1, and then anything after 1 is many. I'm not kidding. Like, it's like if you, I forget what the name of the culture is, but there's a culture in Africa where I saw an interview with this guy where they were asking him, how many kids do you have? And he said, many. And they're like, yeah, but how many? And he was like, many. And like, they would ask him something, and his answers, like, depending on the number of things, were either 1, if there was only 1 of that thing, or many, if there was more than 1. And so, like, this idea of human beings learning to count distinctions between 1, 2, 3, 4, 5, 6, 7, it's about 20,000 years old, and imagine a world where we didn't do that. It's crazy. Anyway.
I get straight A's.
The answer to this one is many. Okay, the next type of numbers we're going to talk about are the whole numbers. The whole numbers still have no fractions, no decimals. The whole numbers is every single natural number, 1, 2, 3, 4, 5, on up to 1,037,000,037, plus 0. So 0 is the only number that's added with the whole numbers. And believe it or not, the idea of 0 is really only about 1,000 years old, as near as we can tell. Before 1,000 years ago, people didn't have a number for 0. They just said that it was nothing, and they didn't actually use a number to represent it, which is crazy. But if you think back to like when you were a kid, when you were learning how to count, no kid counts 0, 1, 2, 3, 4, 5, 6, right? Have you ever seen anybody do that? It'd be weird, right? So 0 is this other thing, and when we add 0 to the natural numbers, it becomes the whole numbers. Brigham.
Why do we have to add? Why do we even have 0?
Because 0 actually serves quite a few interesting functions in math. First of all, did you know that 0 is an even number? It's an even number, believe it or not. If it weren't an even number, then you would have a gap in your even numbers, because -2 is even, and +2 is even. You have to have something in between them, which means 0 is even. Like 0 serves a bunch of interesting functions, but it's relatively young as far as numbers are concerned. Okay. After natural numbers and whole numbers, somewhere along the way, like when you're learning about numbers, you learn about owing people stuff, like I owe you 2 or I owe you 3 or whatever. This is where the integers come in. The integers are all of the whole numbers and all of the natural numbers and their opposites. And by opposites in this case, I mean -1, -2, -3, ... on out to negative infinity. So still no fractions, still no decimals, right? So we've got the natural numbers, starting at 1 and then counting up by 1s as high as you can possibly count. We've got the whole numbers, which is all of the natural numbers plus 0. We've got the integers, which are all of the whole, all of the natural numbers plus their opposites. And now after this, somewhere along the way, like about 4th grade, we start shoving fractions down your throat. And that's where the rational numbers come in. A rational number, like the key to understanding it is in its name, is anything that can be written as a ratio of 2 integers. You guys remember what a ratio is?
Yeah.
Okay, so anything that can be written as a ratio of 2 integers, like saying -2 over 3, this could be read as -2 to 3. And so this is a ratio of 2 integers, so it's a rational number. Another thing that's a rational number could be something like 0.1 repeating. Any decimals that repeat are rational numbers. 0.25. Any decimals that terminate are rational numbers. You can get your pencil. It's fine. 0.25 could also be written as 1/4, so that makes it a rational. 0.1 repeating could also be written as 1/9, so that makes it a rational number. So any number that can be written as a decimal that either repeats or ends is a rational number. It can be a ratio of 2 integers. Kinda sorta? Alright. So now over here in this box off to the side, we've got the irrational numbers. Alright. Now the irrational numbers are numbers that if you make them into a decimal, the decimal never repeats and never ends. It goes on for forever. Can anybody think of a famous number that as a decimal never repeats and never ends? Yeah, Brooklyn. Pi. Absolutely. Pi is the most famous irrational number. You cannot turn it into a fraction, and if you write it as a decimal, it goes on for forever and never ends. Okay, and never repeats. Some other irrational numbers here I'm going to show you are things that are square roots of non-square numbers. So like the square root of 2, or the square root of 13. These are irrational numbers as well. So just to give you like a brief description to make sure that, yeah, Brigham.
Like how far have people gone, like writing down pi?
Writing it down, I don't know. I know that the record is, I want to say 10,000 digits. Like somebody has spoken aloud the first 10,000 digits of pi accurately.
Like he wrote them down and just like went...
No, he spoke them. He had them memorized in his head. He went into a room and he spoke them aloud.
Memorized?
Mm-hmm.
Was it someone with photographic memory?
I don't know. I know that like there's an annual pi competition, and yeah, where people. Okay, so never end. So irrational numbers as a decimal, these never repeat and never end. Rational numbers as a decimal either end or repeat. Bless you. And then everything that's on that page, including the irrational numbers, everything that's on that page is a real number. So, what I want to do here is just kind of like show you guys how these circles work, because it's one thing for me just to have you fill them in, and it's another thing for me to kind of help you understand the way that this works. So if I choose a number, like let's say I choose the number 10. All right. So first of all, is 10 a natural number? Yes or no? Okay, so it's a natural number. Is it also a whole number? Yes, because all of the natural numbers plus 0 are the whole numbers. So, since 10 is natural, 10 is also whole. Is 10 an integer? Yes. So 10 is a natural number, it's a whole number, it's an integer. Is it a rational number? Can we write it as a fraction?
Yeah.
Yeah, we can write 10 over 1, so that makes it a rational number. Is it a real number?
Yeah.
Okay, it's on that piece of paper, so it's a real number. Is it an irrational number? No. If you were to turn 10 into a decimal, would the decimal end or would it repeat? It ends, which means it can't be irrational. Irrational numbers are decimals that don't end and don't repeat. Okay? Does that make sense? Okay. So 10 is all of these things. What about like -2 sevenths? Is this a natural number? No. When you're learning how to count, does anybody go -2 sevenths, -1 seventh, 0, 1, like no. It doesn't happen. So it's not a natural number. Is it a whole number? No, it is not a whole number. It is an is it an integer?
No.
No. Is it a rational number?
Yeah.
Yes, because it is a ratio of two integers. So it's no to natural, no to whole, no to integer, but it is indeed a rational number. And then, is it a real number? Yes, it's something that would be on that page, so it's a real number. So some numbers can fit into as many as 5 categories. Some numbers can only fit into 1 or 2. Okay, let's try out pi. Yeah.
How is 10 an integer? Isn't that
The
just
integers,
negative?
so thank you for asking. This circle that has the integers is the circle that would have 10 inside of that bigger circle. Right?
Like, what do you
So, okay, like integers is this kind of circle right here, right?
yeah.
Anything that is inside that circle is still an integer. So like 0 is an integer because 0 is inside this big circle.
Oh. Okay. Yeah.
You with me now?
Yeah.
10 is inside the natural number circle, but that circle is inside the integer circle, so 10 is an integer. Does that make sense?
Yeah.
I'm sure you're not the only one who would have asked about that. So same thing with the rational numbers. Like 0 is a whole number. The whole numbers are inside the integers, which means 0 is also an integer. And then the integers are inside the rational numbers, which means anything that's an integer is also a rational number, because it's inside that other circle. That's why I drew this diagram like that.
Alright.
But anything that's irrational is off to the side and isn't a part of any of these circles. So like if we're looking at something like pi, is pi a natural number? No. Is it a whole number?
No.
Integer? Rational?
Nope.
No. What is it? It's irrational, and what else is it? Real. So pi is none of these things, but it is irrational, and it is real. Kind of, sort of? Alright, so now, how this would show up is on a quiz I'm probably going to give you guys next Thursday. Hint probably means I'm going to. I will give you like a number. For example, I might say the number 0.4 repeating. And I will ask you, to which number systems does 0.4 repeating belong? So first of all, is it a natural number? Is it a whole number? Is it an integer? Here's the tricky part. Is it a rational number? Yes, because it repeats, right? It will never end, but it repeats. So 0.4 is a rational number, and what else is it? It is a real number. Everything that we're going to talk about until maybe third quarter, we might get into numbers that aren't real. Everything we're going to talk about are real numbers. So 0.4 repeating is a rational number, and it is a real number. Both. Yes, because rational numbers are things that don't repeat. Or sorry, rational numbers are things that either end or repeat. So if I were to do like 0.1275 and have that be the end of it, it doesn't repeat, but it ends. And decimals that end are rational numbers. Decimals that repeat are rational numbers. Does that make sense? It would be irrational if like you did something on a calculator and got a screen full of decimals that never repeat and never end. That sort of? Alright. Hannah.
I know like it can't be rational and irrational, but irrational says it can never end, and point four would never end.
Right, it has to be both. It has to be something that doesn't end and doesn't repeat. It has to be both of those. Whereas rational can be one or the other. Rational, it can be a decimal that ends, or it can be a decimal that repeats. It doesn't have to be both. Whereas irrational, it has to be both. Does that make sense?
Yeah.
Okay. You sure you're not the only one who had a question? Alright. Does this make a little bit of sense? Alright, we're going to revisit this as we go on. So, very possibly this will be on tomorrow's warm-up, so be aware of that. Take this paper, put it somewhere that you can keep it safe. If you have a three-ring binder, put it in there. If you have a folder, put it in there. If you can fold it up and put it in your notebook and be reasonably sure that you're going to take care of it, put it there. Okay? Now, we're going to take a little bit of more notes today. So I'm going to show this as being on just plain notebook paper. That's where I would recommend you do it. If you do not have paper, please let me know. I will give you some. I'll even give you a folder so you can keep your notes in my classroom if you want to. But, all right. So today we're going to talk a little bit about the order of operations. Order of operations. All right. And I told you before that the order of operations, I always think of them as being please email my dad a shark. So parentheses, exponents, multiplication and division, and then addition and subtraction. So you might have heard please excuse my dear Aunt Sally. I think that's boring and lame. So I always call it please email my dad a shark. Now, as far as an extra credit project for this first quarter goes, this is your extra credit opportunity. I want you guys, and you can choose to do this, you can choose not to do this. This is not an assignment, this is extra credit. If you want to, you can try and come up with another acronym. Do you guys know what an acronym is? Something like CIA or PEMDAS, something that stands for something else. I want you to come up with another acronym for the order of operations, and then make a poster out of it. That poster doesn't have to be super nice. It could be just a single sheet of paper with like your acronym on it. Like say for example, pink elephants might dance around spontaneously. That could be an acronym for PEMDAS. And then just have a little poster with that on it. That make sense?
Like post the posters everywhere.
I will post the ones that I get. An example of one that I've gotten in the past that a student let me keep is this one. Pancake explosion. Many deaths are suspected. And then he drew like an exploding house of pancakes with a bomb on it and like police tape. The exploding house of pancakes. I thought it was funny. Anyway, I'm going to give you extra credit based on how much effort I think you put into it. So I'm not assessing it based on how artistic it is or how nice it looks. It's how much effort I think you put into it. Yeah.
But does it have to be on postboard?
No.
Okay.
No, you could just take like a blank piece of paper, just write on it your PEMDAS expression, and hand that in, and that would count.
Do we have to put a picture on it?
No. I am assessing how much extra credit you get based on how much effort I think you put in. So if you make it colorful, that's awesome. If you're not super artistic and you don't want to draw a picture, you don't have to. You just have to make it as, like, I don't know, so it looks halfway decent. Yeah.
That guy by the pole, was he like a detective?
I think that's what it was supposed to be, yeah. So that's before the end of the quarter, so you have plenty of time to work on that if you want to, or not. You do not have to do it at all. Okay? But that is an extra credit opportunity for the class. So, there we go. Now, one thing with the order of operations is I want to make sure that you guys know that multiplication and division happen at the same time from left to right. From left to right. And then addition and subtraction happen at the same time from left to right. So just because M comes before D doesn't mean that multiplication always happens before division. It's the multiplication and division from left to right and the addition and subtraction from left to right. Okay? And we're focusing on working without calculators right now. Right? Right. So, let's take a look at an example of a question here that might be a little more difficult, and I just kind of want to go through it with you guys, how you would kind of go through this one step at a time. So I'm going to do two sets of parentheses here, opening up. And then in the first set of parentheses, I'm going to do 5 plus 2. I'm going to close that first set of parentheses. I'm going to do this times 3. And then I'm closing both sets of parentheses. So I've got this one big set of parentheses around both things, and then the 5 plus 2 is in a set of parentheses, and the 3 is in another set of parentheses, smooshed up against the 5 plus 2. All right, then I'm going to do divided by, and then in the next set of parentheses, I'm going to do 6 plus 1 and close it. All right. Now, according to the order of operations, according to please email my data shark, what do I need to do first here, John? Parentheses. So which, like specifically, which one of these happens first? Okay, what does 5 plus 2 turn into? 7. All right, cool. Now, when I drop down the 3, because there was nothing in that set of parentheses, is it 7 times 3, plus 3, minus 3, or divided by 3? Times. Cool. So I've got 7 times 3 here. What's another set of parentheses I need to deal with, Jonathan?
6 plus 1.
Which is?
7.
Awesome. Okay, cool. According to the order of operations, what do I need to do next, Jenna? Which is? And then I've got divided by 7 over here. And then what's last, Sam? Yeah, 21 divided by 7. And what does that spit out? 3. So the final answer is 3. Not too bad, yeah? You guys should have seen these last year and maybe the year before, hopefully. Order of operations. Cool. Now, I'm going to throw some algebra in it because you guys are in an algebra class. And what algebra means is that means I'm going to start throwing in some variables, which you still probably saw last year. So I'm going to write something with variables that looks super complicated, but I promise you it's not that bad. I'm going to write m times, in parentheses, p divided by 4, close parentheses, squared, plus q, close parentheses. But I'm going to tell you what each of those variables means. I'm going to tell you that m is equal to 3. I'm going to tell you that p is equal to 8. I'm going to tell you that q is equal to 2. Have you guys seen this kind of problem before? Yeah. Hannah, yeah. Because I'm telling you which order I want things to happen in. So when you're looking, if there's more than one set of parentheses, you're going to do the, so parentheses first. So you're going to look at this big set of parentheses, right? And then inside that set of parentheses, you're looking for what to do first. And you're going to do the parentheses inside of that first. So like it's a way of ordering things. Like I'm saying that in this big set of parentheses, you're going to do this set of parentheses first before you do the times 3. So that's what it means. It's a way of ordering stuff. And if you have more than one set, you do the innermost parentheses first and then work your way up. Jenna? Sure, absolutely. If it confuses you to use 2 sets of parentheses, if you want to use a square set of brackets for the outside, you can. Absolutely. If you don't want to, if square brackets scare you, you don't have to. Okay. All right, now, the first thing I'm going to do here is I'm going to take what those variables are equal to. I'm going to put those numbers in so I have numbers to deal with. So m was 3, so where I see m, I'm going to replace it with a 3. P was 8, so I'm going to replace P with 8. And Q was 2, so I'm going to replace Q with 2. Alright, so now that looks not too bad. I mean, it still looks a little scary, like you wouldn't want to meet that in a dark alley late at night, but it's not that bad, right? So I'm going to do one of these things first. So parentheses says I'm going to look at the big set of parentheses, and then look at what I need to do in there. So inside the big set of parentheses, there's another set of parentheses, so this happens first. This 8 divided by 4 goes first. So what is 8 divided by 4, anybody? 2. So I'm going to do 2, and then it's 2 squared, plus 2 inside that set of parentheses, times 3 on the outside. All right, still parentheses first. And then inside the parentheses, I've got an exponent and I've got an addition. What do you do first? So this is going to be 2 squared is what? 4. And now I've still got parentheses. So inside the parentheses, what do I do? Which is 6. And then I've got this 3 smooshed together outside the parentheses. So what do I do with that? Multiply. So this turns into 18. All right? Kind of, sort of? Yes, no, maybe so? All right, sweet. So, I'm going to give you guys an assignment. It's not that bad, I promise. You guys can work together on this if you want to. You can work alone if you like, but no calculators.
Can we move our desks again?
Yeah, you can move your desk. Alright, and I'll be coming around just to see if anybody needs any help or anything like that. So, feel free to ask questions. This assignment we will correct in class tomorrow. So, for any of you, if you finish it today, before class ends, then you can hand it in. You don't need to wait for me.
How many points is it?
This one we're going to say a point a question, so 30 points. Some assignments will have more than a point per question. Oh, and I'll turn it.
Do you want a specific color to be graded in?
No, I'll pass out the markers when we grade.
Okay. So you don't want us to use pens?
You can use pen. Like if you have your own marker you want to use, that's fine.
Okay.
But I don't want you to it should be something different than what you use to write with. That's fine.
Use blackboard.
Yeah, that's fine. So long as it's not like what you did the assignment in, that's fine. The reason why is I don't want you, since I allow you to do corrections, I don't want you writing the answer next to your incorrect answer, so that then you just have to go back through and rewrite that. That's no bueno. Maybe not. Okay.